So we're going to look at inverse trig notation. And you might see this in a couple different forms. The form you're familiar with is this first one, which CPM has been using, but I want to give you another form also. You might also see this as arc sine of x or arc cosine of x. It's just a different way of representing it. It's actually, if we translate this into words, it means the arc in terms of that part of the circle. So it connects it to the circle a little bit better, or in a more meaningful way. This is very important because students often confuse this. Sine to the negative 1 isn't sine to the negative 1. It's not 1 over sine of x or 1 over cosine of x. Yeah, because you're thinking right away, what's 1 over sine of x? Cosecant, and this is secant, right? Why would a student want to do this based on this form? Negative exponent, they think we need to flip it. But this means the inverse, okay? It's a different way of representing it. I know that can be a little confusing. So please don't do this, because you'll be with the reciprocal identities. All right. Okay, now that we have that, we'll probably just have time to do the part on the top. So in thinking about the inverse, we're going to think we're undoing a process or going backwards. We haven't done the algebra for this yet. We'll look at it more later. This is more the graphical approach. Yeah. Yeah. And let's look at sine. And this is kind of very similar to what we did earlier, just putting it in a more organized format. So let's say sine inverse of rad 2 over 2. And this is how you would see it on an assessment if I wrote it this way. And I tell you explicitly, find the inverse sine of this. And you only need one solution. Another way of saying this, and here's why we use arc sine, or where it came from. The arc whose sine is blank. This is what it translates to. And I think when I draw the circle it will make sense. The arc whose sine is rad 2 over 2. What does sine mean, x or y? Y values. Okay, so it helps you, I think, just to keep translating. And the arc is going to be that radian measure. So this is our theta. The theta whose y value is blank. Now let's draw the circle, and this will help us get at it. Go ahead and label this as our unit circle, radius of 1. Now we solved this earlier, right? Go ahead and tell your neighbor, where is the y value equal to rad 2 over 2? There's two places. Pi over 4 and? Alright, let's go ahead and mark that. Pi over 4 and 3 pi over 4. So we know pi over 4 is one of them. And we know that, sounds like an air raid siren. I think they're just testing stuff. I love how if we were getting bombed, like Dana would know about it, and we'd just be like, alright, we practiced for a shooter drill, but we didn't practice for the bomb. Barricade the doors. I don't think that would help in a bombing. Well, that's, I mean, totally like during, I should probably pause this. I'm recording myself right now. Okay, so to do this, we knew there were two solutions, but if we're taking the inverse and we're only looking for one, we had to restrict the range. And the restricted range, we did it right along here, was from negative pi over 2 to 3 pi over 2. So we can write that down here. Negative pi over 2, and pi over 2. So our domain now is negative 1 to 1, and our range, actually I should be more explicit, our restricted range is negative pi over 2 to pi over 2. Now, some of you might have noticed that, I mean, maybe you didn't notice. It's fine if you didn't. Back when we were doing chapter 4, our domain was always radians, right? And our range was always negative 1 to 1. Why have these switched? We're dealing with the inverse. Very good. So this is the inverse operation, and that's why we've switched them. Okay? So if we were to evaluate this on this restricted range, you've done it earlier, x equals pi over 4, and it equals 3 pi over 4. But what's the only solution that works on the restricted range? Pi over 4. So we could actually cross that one out. Now,